Now we have X consumers of type 1 and 1 minus X consumers of type 2. Consumers type 1, type number of consumers of type X, and here 1 minus X. Then every consumer has a unit demand for a good which comes in two varieties, basic and fancy. Here we have maximum willingness to pay of both types, fancy and basic. 12, 6, 5, 3. Good. Point A. Find the firm's highest profit from selling only fancy as a function of X. Easy, yes? If we sell only fancy, what are our options? What prices we will charge?
12.
12 or 5? If we will charge price 12, only first type. First type. And what will be our profit?
12.
No.
Multiplied by X.
12 multiplied by the number of such consumers, amount of such consumers, X. 12X. If price equals to 5, both, multiply both. And profit will be 5 multiplied by X plus 5 multiplied by 1 minus X. 5. Good. And we can consider, yes, for which X's we will charge. We can write that profit will be 12X if 12X is bigger. Yes. 12X bigger than 5, it's when X bigger than 5 over 12. And vice versa, profit will be equal to maximum. Will be equal to 5 if X less or equal than 5 over 12. Easy. Next. Let's write that X belongs from it's between 0 and 1, so better to write here 0. And 0 and 1 we do not include. Point B. Point B is a little bit harder. Find the firm's highest profit from selling fancy to the first type and basic to the second type as a function of X. So we should sell fancy to the first type and basic for the second type. If we want to sell like this, we need to set such prices such that first type will want to buy fancy and second type will want to buy basic, such that they will not switch to other product. So we should write down conditions for their incentives to buy the product that we want to sell to them. Yes, so first of all, we can write down profit maximization program with restrictions. What we will maximize? We will maximize profit from selling to both types. It will be price fancy good. We will sell to the first and its number of first type X is multiplied by X quantity that they will buy, plus the price of basic good multiplied by 1 minus X. Yes. Yes. So we want to charge. We need to charge these prices by choosing prices for each type non-negative. Subject to, we need to write down restrictions. First of all, I think lectures, you considered such restrictions. It's individual rationality and incentives compatibility constraints. Yes? So first of all, our consumers will want to buy the good. Yes, it's better to buy than not to buy. It's individual rationality constraint. Individual rationality constraint for the first type will be it's a first type surplus from buying the good. First type will buy fancy, yes, and what will be it's like surplus from buying fancy 12, yes. So now I have good that I value as 12. So this will be 12. It's my pleasure for consuming this good, but I paid the price. So it will be minus price of fancy good. And this is this consumer surplus for each consumer of type 1 should be a negative. So if that works, that means that I want to buy the good. It's better for me to buy than not to buy. So the same, let's write down for the second type. Second type will buy basic good. Basic good it values as 3. Is the pleasure from consumer is 3. And second type will pay price for basic good. And this should be also non-negative. Now, let's write down 2 other conditions. Incentives compatibility constraints. For the first type, we need for the first type that the first type will buy fancy, not basic good. Yes. So if first type will buy fancy good, you will pay 12 minus fancy price for fancy good, and this surplus should be bigger than if our first type will switch to buying basic. If first type will buy basic, it will have 6. Yes, pleasure 6 minus price of basic good. So 6 minus price of basic. And the same we will write down for the second type. We need second type to buy basic good, not fancy. Basic good for the second pleasure 3 minus price of basic should be bigger or equal to the situation when second type will buy fancy good. Second type is 5 minus price of fancy. 5 minus price of fancy. So this is very, very big maximization problem. Also, you can solve it analytically. All these constraints you can solve analytically and decide which constraints will be binding. What means binding with equalities? Yes, and which constraints will be with strict inequalities. Yes, and then put these constraints with equalities into the maximization program, and from here we'll find the prices. But I think it's also not too easy analytical solution. Let's do a graphical solution. So we need to draw 1, 2, 3, 4 areas. Yes. Here will be price of, let's say, basic. Here will be price for fancy. So first line, price of fancy equals to 12. Price of fancy equals to 12. This line. Yes, and this is IR, with the rationality for the first. Then the rationality for the second, price of basic equals to 3. Price of basic equals to 3, somewhere here. Then here we write price of fancy equals to 6 plus price of basic. 6 plus price of basic. And incentives compatibility for second, price of fancy equals to price of basic plus price of basic. So they will be parallel, these two lines. Yes, but they start from 2 and from 6. From 2. And the slope is 1. This slope is 1. And from 6. 6, 3. This is incentives compatibility for the second. This is incentives compatibility for the first. Which area we'll consider? So let's see. Price of fancy should be less than 12, so under horizontal line, to the left from the vertical line, and between these two incentives compatibility. So we will consider this area. And from here, we should decide on prices that we will charge that will give us maximum profit. It will give us maximum profit. Which prices it will be? It will be a corner. Yes. Why? Because the higher the price, each price, the bigger our profit. Yes. Bigger. So this will be the price of basic, and this is the price of fancy. Price of basic equals to 3. We see this, yes, from the graph. Price of fancy, let's find. Yes. So price of fancy will be, it is the cross of incentives compatibility for first. It's going to be 6 plus 3, 9. Yes. Price of basic equals to 3. Good. And what will be our profit? Profit from selling such options. Maximum profit will be for price 9. We will sell to the first type and amount of first type X amount of consumers. So this will be 9 multiplied by X. Yes. Plus 3 multiplied by 1 minus X. It is 6x. It is 6x plus 3. Agree? And last point C. Point C. Our question is for which x it is better to offer both versions. Yes. Better to offer both options. So both versions, it's point B. One option only fancy, it's point A. When it's better to offer both, the profit from offering both is bigger, yes, than from offering only fancy. So when it will be solved, when profit 6x plus 3 will be bigger than 12x and bigger than 5. Okay, bigger or equal to 5. X plus 3 at the same time. So it's better to offer both versions. Let's solve it. So here will be x bigger than 2 1/3. Here x 3 over 6 less or equal than 3 over 6, it's 1/2. So answer, if x belongs from 1 over 3 to 1 over 2, it's better to offer both versions. So that's all. Thank you.